Everyone thinks hallucinations are a model problem, but they aren't. Your engineers point at the LLM and say, GPT-4 is making stuff up, while your security team nods and your executives frown. You all start trying to fix the AI with better prompts, newer models, and fancier safety guardrails. But here is what is actually happening. You have built an orchestration disaster that systematically rewards confident lying. Your Copilot isn't broken, and in fact, it is working exactly how you designed it to work. By the end of this masterclass, you will understand how to build a Copilot that confidently hallucinates, and more importantly, you will know exactly how to tear that machine apart. This isn't just a theory because it serves as a diagnostic tool for your entire architecture. The stakes are real right now. The difference between a helpful draft tool and a compliance nightmare is whether you have engineered for truth or just for fluency. Right now, you have probably engineered for fluency. Why LLMs hallucinate by design? Let's start where the hallucination actually begins, which is deep inside the training process. Large language models are not knowledge retrieval engines, but instead they are next token predictors. You feed them a sequence of words, and their only job is to calculate which word most likely comes next. Then they add that word and repeat the process over and over. That is how they work. This matters because the training signal they receive is entirely about fluency and completion rather than truth. When you fine-tune a model with reinforcement learning from human feedback, which is the standard RLHF process, you are telling the model to maximize what feels helpful, natural, and authoritative. You are not telling it to maximize accuracy. In fact, you are doing the opposite. Think about what happens when a model encounters a question it cannot answer from its training data. It has two choices. It can say it doesn't know, or it can generate something that sounds plausible, coherent, and confident. What do you think gets higher marks from human raters? A simple "I don't know" rarely wins against a smooth, detailed, and well-structured answer that sounds like it came from an expert. The model learns fast, and it realizes that confident guessing beats honest uncertainty every single time. This creates a fundamental incentive structure. The entire RLHF loop teaches models that sounding right matters more than being right. So a hallucination that is fluent and structured gets rewarded, while an honest admission of uncertainty gets penalized. Benchmarks only make this problem worse. Almost every major AI benchmark like MMLU or GPQA uses binary scoring, which means you either get it right or you don't. There is no credit for saying you are not sure or that a topic falls outside your reliable knowledge. In fact, saying that costs you points, so the model optimizes for getting points by guessing confidently when it is uncertain. Consider the math for a moment. If you are being graded on a multiple-choice exam and you don't know the answer, you can leave it blank and get 0 points, or you can guess and have a 25% chance of being right. The guess is what maximizes your score, and so the model learns that when it doesn't know something, it should guess with total confidence to win. This is the fundamental mismatch at the heart of LLM training, because the models optimize for pattern matching. They learn correlations in massive amounts of internet text, so when they see Paris is the capital of, they have learned that France follows with high probability. That is just pattern matching. But truth is not just pattern matching, and it requires grounding by connecting symbols to reality. Models trained on next token prediction have no mechanism to do that, so they cannot distinguish between a fact that appeared a million times and a falsehood that appeared once. They cannot know which sources are reliable and which are fabricated, and they cannot understand what actually happened in the world versus what just gets written about frequently. Yet they sound like they can, and that is the danger. The model has learned to sound authoritative precisely because authority is rewarded, and confidence and completion are rewarded too. Truth is merely one signal among many, and often it is not even the strongest one. This is where the machine learns to lie. It isn't trying to be deceptive, but it happens because you have trained it to optimize for everything except what actually matters. The data problem, training on internet noise. But here's the thing. Even if you solve the training incentive problem, and even if you somehow convince the model that honesty beats confidence, you would still have a bigger problem. Your model was trained on the entire internet, or at least a massive slice of it, and the internet is not a reliable source of truth. The training corpus contains contradictions. It contains conspiracy theories sitting next to peer-reviewed science, and it contains outdated information that was true 5 years ago but is not anymore. It contains deliberate falsehoods, misinformation, and opinion presented as fact. All of it is mixed together. The model has no way to distinguish between them. When you train on billions of tokens scraped from web pages, forums, and social media posts, you are feeding the model a corpus that reflects human disagreement and human error at scale. The model learns the patterns in all of it, but it does not have a mechanism to say that one source is reliable and another is not. It learns correlations. It does not learn truth. Consider a specific example. Somewhere in the training data, a fact appears about when a particular CEO took office. That fact appears once or twice in an obscure blog post or a rarely visited Wikipedia edit history. The model sees it once and it ingests the pattern. Meanwhile, the same fact appears in a different, incorrect version thousands of times. Maybe it is a common misconception, Or maybe it is part of a meme that got repeated across the web. The model sees this wrong version hundreds or thousands of times. Now you ask the model about that CEO, which version does it draw from? Probability favors the common version because of distribution imbalance. The model has learned that frequently repeated patterns are statistically more likely to be right, but in this case they are not. The falsehood wins. This is distribution imbalance acting as a hallucination engine. Rare facts do not get encoded reliably, but common myths do. When the model encounters a query, it cannot ground in high-confidence patterns. It fills the gap with whatever pattern is statistically most plausible, regardless of accuracy. In enterprise RAG, this problem gets worse because you have added a new layer of noise. You are not just inheriting the internet's contradictions, you are inheriting your organization's own data chaos. Your SharePoint has old policies sitting next to new ones, and your documentation is a graveyard of deprecated procedures that nobody bothered to delete. You have got draft documents mixed with final versions, and you have got personal notes that look official. When you index all of it and let Copilot retrieve from it equally, you have created a data distribution problem inside your own walls. Old guidance ranks just as high as new guidance, and a stale policy retrieved from an archived team site competes with the current policy from the official library. The model has no way to know which is current. It just knows both are retrievable, so it pulls from both, or it pulls from whichever ranks slightly higher by semantic similarity. If it is not confident, it synthesizes, it combines elements, and it invents context to make the contradiction disappear. You have built a hallucination engine not because the model is flawed, but because your data is fundamentally untrustworthy. It is noise masquerading as context. Now let's talk about how you actually build this into your system. Retrieval as a hallucination engine. Now imagine you have indexed all that chaos. You have got a vector database full of everything, including current policies, old versions, and drafts that your users can technically access. Copilot is live. A user asks a question. What happens? The retrieval system springs to life. It encodes the question as a vector, and then it searches for semantically similar chunks in the index before returning the top results. And this is where the system breaks. Retrieval systems do not return all relevant results. They return the most relevant results, often called the top-car results. Usually, this is the top 5 or top 10, depending on your context window budget. That is a hard constraint because you cannot fit everything into the prompt. You choose the best matches according to your similarity metric. But being the best match by cosine similarity is not the same as actually answering the question correctly. Consider what happens in practice. Your Copilot receives a query about expense policy. The retrieval system finds 50 documents mentioning expense policy, but it only returns the top 5. Those 5 include 3 documents from the current HR site, 1 old draft from an archived team, and 1 external blog post about general expense management. The model receives all 5. It has no way to know which ones are current, and it has no way to know that one is deprecated. It just sees 5 documents about expense policy that all rank roughly equally in terms of vector similarity. So it synthesizes, it pulls context from all of them, and it blends the old guidance with the new guidance. It adds confidence and structure to the contradictions. The result is a hallucination. This did not happen because the model invented facts, but because retrieval gave it conflicting signals and no way to resolve them. This is the inexhaustive retrieval trap. You cannot retrieve everything, so you retrieve what you think is most relevant. But relevance metrics are not the same as correctness. A document can be semantically relevant to a query and still be operationally wrong. Context windows make this worse. Modern models have large context windows, but even with a large window, you cannot fit your entire knowledge base. So you still choose. You still truncate. You still send the model a subset of what exists. And in that subset, important context gets buried. There is a phenomenon in retrieval research called lost in the middle. If you give a model 10 documents, the critical information in documents 6 through 9 often gets ignored. The model attends to the beginning and end, while the middle gets lost in the noise. So Copilot retrieves a ranked list. Your most relevant document is number 1, and your least relevant is number 10. The model processes them. But when you ask it a follow-up question that depends on information from document number 7, it either hallucinates an answer or contradicts what it said earlier. It lost track of the middle. Permission sprawl amplifies this disaster. Your SharePoint has overshared libraries and your team's channels have guest access. Copilot retrieves based on what the user is technically allowed to see, not on what they should see. A user with broad permissions gets broad retrieval, and they see sensitive documents mixed with public ones. Stale content competes with fresh content, and drafts rank alongside finals. The retrieval system does not distinguish between them, it just returns the most similar vectors. Lifecycle management failures weaponize this completely. If you index everything without dates or deprecation flags, then old guidance never stops being retrievable. A policy from 2019 remains in the index, it is still in the vector space, and it still matches queries about that topic, it still gets retrieved and ranked. So you ask about current benefits eligibility. The system returns the 2019 benefits policy. Nobody noticed it was deprecated, and nobody marked it obsolete. It is just sitting there, semantically relevant but completely wrong. This is retrieval as a hallucination engine. It is not because the model is broken. It is because the retrieval system hands the model conflicting, stale, and noise-heavy context, and the model does what it was trained to do. It synthesizes a confident answer from whatever it is given. But retrieval is only half the problem. The grounding failure, when context becomes liability. Grounding is supposed to be your safety mechanism. The theory is simple. You retrieve context from your knowledge base. You put that context in front of the model. The model answers based only on what is there. It's bounded, it's verifiable, it's safe. But in reality, grounding becomes your liability. The problem starts with how you actually assemble the prompt. You retrieve 10 documents and chunk them into pieces. You strip away the metadata and concatenate the text into one giant, messy blob. Now you have a prompt that looks like a wall of text. It has system instructions at the top and the user's question at the bottom. Then you add a final command, answer based only on the provided context. You think you've built a cage for the AI, but you haven't. What you've actually done is hand the model a pile of weak evidence and told it to build a house. The documents you retrieved aren't all the same. Some are official policies, while others are just edge cases or old discussions where people disagreed. The model receives all of it at once. Everything is flattened into the same format. There are no signals telling the AI which document actually matters more. This is the too much context problem. The assumption is that more evidence equals better answers, but it doesn't. At a certain point, adding more documents doesn't clarify the truth. It obscures it. The model has to synthesize across conflicting statements and navigate contradictions. And when it tries to make sense of the mess, it hallucinates. It doesn't just invent facts from thin air. It blends facts from your context to produce something entirely new. It creates an answer that wasn't in any single document, but feels like it should be true. If document A says the policy requires X and document B says it requires Y, the model might synthesize a third interpretation. That interpretation satisfies both documents, but it isn't real. It sounds grounded because it cites sources, but it's a total fabrication. This is the citation illusion. You ask the model to cite its sources and it points to document 5. It pulls a quote that actually exists in that document. But here's the problem. That quote doesn't actually support the claim the model just made. The AI used the quote as cover for an inference it made up. The citation is real, but the logic is a hallucination. You end up with confident, wrong answers backed by plausible sources. Retrieved chunks often mislead the model because they are fragments without a soul. A policy might explain a rule in paragraph 7, but paragraph 3 contains a constraint that changes the entire meaning. If you only retrieve paragraphs 3 and 7, they will look like they conflict. The model doesn't have the rest of the document to understand why that conflict exists. Because it lacks the full picture, it invents a way to reconcile the 2 points. Data quality corruption now runs through your entire pipeline. Your retrieval gave you mixed quality sources. Your prompt didn't weight them correctly. Your instructions said, answer based on context, but didn't say what to do with contradictions. The model filled the gaps because it had to. You gave it incomplete information and demanded a complete answer. The deeper issue is that you confused more context with better grounding. You thought that if you just shoved enough documents into the prompt, the model would eventually find the right answer. But retrieval isn't the bottleneck anymore. Synthesis is. The model is incredibly good at synthesis. It is literally trained to combine information in ways that feel coherent. When you give it 10 documents full of gaps, it fills them. It produces something that sounds authoritative and complete. What you don't see is whether that synthesis matches the real world. Grounding was supposed to prevent this by making everything traceable. In theory, hallucination becomes impossible because the model can only use what it was given. Except it doesn't work that way. The model doesn't just rearrange the pieces you provide. It infers and produces novel combinations that feel grounded even though they were never stated anywhere. And this is where the orchestration layer becomes critical. Identity propagation as a silent failure. This is where the system becomes genuinely insidious. Everything we've talked about so far gets amplified by a single decision. It's a decision you made years before Copilot even existed. You made choices about who can access what in your Microsoft 365 tenant. Some of those decisions were smart, but most were just pragmatic. A department needed a SharePoint site, so you clicked Create. A cross-functional team needed a place to talk, so you gave everyone broad permissions. A partner needed to see a few files, so you added them as a guest. You did what made work easier at the time. Now, Copilot inherits every single one of those choices. The system doesn't retrieve information based on what you're trying to do. It retrieves based on what you are technically allowed to see. Whatever a user can access becomes part of the AI's library. If a user has been added to 50 sites over 5 years of reorganizations, Copilot sees all 50. Some of those sites are dormant, some are from projects that ended in 2019. Some contain sensitive data that the person shouldn't be looking at anymore. It doesn't matter. If the permission exists, Copilot can retrieve from it. This transforms a messy SharePoint environment into a massive source of hallucinations. The documents aren't lies, but they are contextually wrong. Imagine a user asks about the current benefits policy. They were added to an HR site 4 years ago when they worked in that department. They moved to finance years ago, but they were never removed from the old site. Copilot retrieves the policy that was current when they were in HR. The policy has changed since then, but the old document was never deleted. The retrieval system pulls the old file. The model synthesizes it with the new one. The user gets an answer that mixes old and new guidance with no way to tell them apart. This is the permission sprawl trap. Every permission you were too busy to revoke is now part of the AI's brain. Every site you added someone to but forgot to clean up is now part of their search results. Identity failures compound when you start doing multi-step workflows. A user asks a complex question that requires 3 different sources. Source A and source B are fine, but source C is something they shouldn't be seeing for their current role. Each individual retrieval is correct according to the permissions, but when they are combined, they create a context that makes no sense for the business. The result is that sensitive or obsolete data starts influencing your answers every single day. Information that was supposed to stay in one room gets mixed into the general population. Old decisions resurface and deprecated guidance gets blended with the truth. This isn't happening because anyone is trying to leak data. It's happening because your permission model was never designed to be a retrieval engine. Why doesn't least privilege exist in most companies? Because building it is incredibly expensive and boring. It requires constant reviews and someone to own every single person's access levels. Most organizations don't have a person in that role, so permissions just drift. They accumulate like dust. They become a historical record of every team a person has ever touched. They are not an accurate reflection of what that person needs to do their job today. That historical record is now the playground for your Copilot. Everything accessible is everything the AI can use. There is no distinction between what is current and what is ancient. There is no difference between intentional access and an accidental invite from 3 years ago. You are working with a permission matrix that has been piling up mistakes for a decade. Now, let's talk about how you actually orchestrate this disaster. The Orchestration Anti-pattern. You have now built a system with deep structural problems. The training incentives are flawed, the retrieval is noisy, the grounding is weak, the permissions are a mess. You might think it couldn't get any worse, but you would be wrong. The orchestration layer is where you actively choose to make it worse. Think of the orchestration layer as the control plane. It is the system that sits right between the user's question and the model's answer. It decides what happens before the prompt reaches the model, what happens while the model is reasoning, and what happens after it generates a response. This is every checkpoint where you could enforce a policy, validate an assumption, or verify a permission. That is orchestration. But here's the problem. Most organizations skip these checkpoints entirely. Instead of building deterministic controls, they let the model decide everything. A user asks Copilot to perform an action, and rather than having a system that asks if the user is allowed to take that action on that data, they let the model itself decide whether to try it. They do not have validation to see if an output complies with company policies. They just let the model generate whatever it wants and hope for the best. This is architectural negligence masquerading as trust in the model. Think about what happens when you build this way. A user asks Copilot to summarize confidential board meeting notes and send that summary to an external partner. The model receives the request, but there is no validation layer to stop it. No one asks if the user is authorized to see those notes, or if that partner is on an approved list, or if sharing that category of document is even allowed. Those checks do not exist. The model just tries to do what it was told. It retrieves the board notes. It generates a summary. It prepares to send it, and nobody stops it, because nothing was ever designed to stop it. The orchestration layer failed to validate the request before processing, it failed to check permissions mid-workflow, and it failed to apply policy before execution. This is what happens when you treat prompts as free-form instructions rather than constrained contracts. You are telling the model to do what the user asks instead of telling it to do what the user asks within specific boundaries. One approach is flexible, but the other is just reckless. Tool execution becomes particularly dangerous here. Copilot can connect to Power Automate, call SharePoint APIs, or trigger complex workflows. When you allow tool execution without verifying authorization, you have handed the model access to systems that require very careful permission checks. But those checks never happen. The model decides which tools to call based on its own interpretation of what would be helpful. It executes them under whatever identity it is running as. If that identity is overprivileged, like a service principal with broad access, then Copilot's tool calls carry that same privilege. A wrong action executed with broad permissions is a recipe for disaster. Letting agents roam free across connectors and data sources is where this philosophy reaches its logical conclusion. You build Copilot agents where each one can connect to multiple data sources like SharePoint, Teams, or external APIs. Rather than constraining each agent to the specific connectors it actually needs, you give it broad access. Rather than limiting which data sources it can touch, you let it discover and access whatever is available. The agent decides what to retrieve, what to query, and which connectors matter. The result is predictable. You get confident, plausible, and completely wrong answers generated from data the agent had no business accessing in the first place. An agent built to answer questions about sales processes might connect to the HR connector to find personnel information for context. It should not have that access, but because nobody set a constraint, it accesses and synthesizes that data anyway. The answer sounds authoritative because the agent found supporting data, but the data is wrong for the purpose, so the answer is wrong. Nobody stopped it at any checkpoint because no checkpoints exist. This is the Orchestration Anti-pattern. You have built a system where every decision point that could catch a problem has been removed. Every validation that could enforce a policy has been eliminated, and every authorization check that could prevent misuse has been skipped. The model has maximum freedom and zero guardrails. The system works until it doesn't, and when it fails with total confidence. But there is a specific way to make this even worse. Prompt engineering for maximum confidence. Now we get to the engineering work. You have built an orchestration layer with no guardrails, set up retrieval to pull from a chaotic corpus, and allowed synthesis without any constraints. Now you are going to embed that entire philosophy directly into the system prompt. The system prompt is where you establish how the model behaves. It is the very first thing the model reads before it ever sees a question from a user. The words you choose in this space matter enormously. Most organizations write prompts that sound perfectly reasonable on the surface. They tell the model to be a helpful assistant, to provide accurate answers, and to stay professional and clear. These sound like they should work, but they really don't. The problem is that being helpful and being accurate often point in completely different directions. When the model is uncertain about the accuracy of a fact, it still wants to be helpful to the user. When you tell it to prioritize helpfulness, it will sacrifice accuracy to get there. A user asks a question, and the model could say it doesn't have enough information to answer. That is honest, but it is also unhelpful because the user walked away with nothing, or the model could generate a plausible answer even though it is uncertain. That is helpful because the user got something and the model learns which behavior you rewarded. So you rewrite your system prompts to make this trade-off explicit. You tell it to prioritize being helpful and providing a complete answer instead of prioritizing accuracy. You tell the model that a user would rather have a detailed response than an honest admission of ignorance. Because that is what you have structurally incentivized anyway, you might as well make it clear in the prompt. Use vague instructions and let the model fill in the gaps. Instead of telling it to answer based only on the provided context, you write something like, use the provided context to inform your answer. There is a massive difference there. The first is a hard constraint that says do not invent things, but the second is just a suggestion. It says the context is one source, but not necessarily the only one. The model can use it, but it can also synthesize beyond it. You have left the door wide open for exactly the kind of inference that produces a hallucination. Better yet, do not mention constraints at all. Do not say to answer only from the provided context. Just ask the question and let the model decide what to use. It will use everything available to it, including retrieval results, internal training knowledge, and patterns it has learned. It will blend them and synthesize them. It will do this confidently because you never told it that synthesis was wrong. You can even encourage the model to be creative. Tell it to fill in any gaps in the information with reasonable inferences. That is an explicit instruction to hallucinate. You have told the model that gaps exist, that its job is to fill them, and that using inference is a reasonable thing to do. The model does exactly what you asked. It infers, it synthesizes, and it produces confident wrong answers because you gave it permission. Make it clear that uncertainty is a failure. Never tell the model it is acceptable to say, I don't know. Instead, frame that as a last resort. Tell it to provide an answer. And only if it is genuinely unable to answer should it explain its limitations. But you structure it so that explaining limitations is the rare exception. The default is to provide something, anything, as long as it sounds coherent. This is prompt engineering for maximum confidence. You are not lying to the model, and you are not telling it to make things up. You are just using language that systematically steers it towards synthesis over honesty. You are making confidence the default and uncertainty the exception. You are framing gaps as something to fill rather than something to report to the user. The magic is that you can do all of this while sounding completely reasonable. You are not saying to lie, you are saying to be helpful. You are not saying to make things up, you are saying to fill gaps with inference. The language is professional, but the intent is reckless. And here is the most insidious part of the whole thing. When Copilot produces a wrong answer, nobody blames the system prompt. They blame the model. They say the AI is hallucinating, but they don't see that you spent weeks carefully engineering a prompt that systematically incentivizes exactly that behavior. Now let's talk about data strategy. Data architecture, sprawl as a feature. You have already built a system fueled by bad incentives, weak controls, and prompts that value sounding smart over being right. Now you are going to build the data layer that makes failure inevitable. The indexing strategy is where you make your most important choice. You need to index everything. Do not be selective and do not curate your data. You should never distinguish between an official policy and a random brainstorm. Your Copilot knowledge base needs to be a perfect mirror of your entire information estate, which really means it needs to be just as messy as your actual organization. This matters because being selective requires you to make actual decisions. You would have to evaluate which documents belong in the AI index and which ones are garbage. That kind of evaluation needs criteria, and criteria require policy, and policy requires enforcement. All of that is hard work, so instead just index everything and let the search algorithm figure out what matters. You can just let Copilot grab whatever it wants. The result is a pile of data that mixes official sources with rough drafts, personal notes, and content that was never supposed to be seen by the public. Your HR SharePoint might have the current benefits guide, but it also has draft revisions from 2 years ago that someone forgot to delete. It has email threads where staff argued about how to interpret the rules and notes from an analyst just playing with ideas. All of that goes into the index, and all of it looks exactly the same to Copilot when it searches for benefits information. The model pulls from all of these sources at the same time. It finds the official policy, but it also finds a draft that says the exact opposite and some notes speculating about future changes. Then it blends them all together. The answer it gives back sounds totally coherent and even cites its sources. Those sources are real, but the answer is a mix of facts and guesses, and the user has no way to tell which part is which. Do not bother with sensitivity labels or Microsoft Purview schemes. Those tools were built to label data and restrict access based on how secret it is. If you use them, you would actually have to enforce them. You would be forced to keep confidential files out of the index and restrict what people can see based on their job titles. That is too much work. It is much easier to just let Copilot decide what is sensitive on the fly. The model is going to retrieve whatever it is technically allowed to touch. If a document is not explicitly blocked, the system treats it as fair game. Because you have no classification, nothing gets blocked. Your confidential financial data is sitting right there in SharePoint, so it gets indexed. When a user asks about company money, the model pulls that private data and shows it to them, because nobody ever told Copilot that confidential actually means something. You should also keep every stale document you have, because they provide what people call context. A policy from 2019 is obviously outdated, but it is still true in a historical sense. It shows how the company used to work, and it might be interesting to someone studying the history of the business. So just leave it in there. Do not archive it or mark it as old. Just let it sit in the index where it can be pulled up alongside current info just because the words look similar. Finally, let external content compete with your internal rules. You have partner resources, competitor reports, and industry blogs, so you should index those too. When an employee asks how the company handles a specific process, they will get a mix of your actual policy and what your competitors are doing. Everything is ranked the same way in the database. The model just mashes it all together into one confusing answer. The consequence is that Copilot treats the entire mess as equally important. The index cannot tell the difference between a signal and noise or a draft and a final copy. Everything is just a set of numbers in a database. It is all equally likely to end up in the final answer. You have built a flat collection of every word your company has ever written. There is no metadata, no hierarchy, and no authority. This is the exact point where governance stops being a safety net and starts becoming a liability. Governance theater, the illusion of control. You have finished building the machine. You have bad training incentives, weak retrieval, and a chaotic pile of data. Now you just need to add one final touch. You need the governance layer that makes your leadership feel safe without actually changing a single thing. This is where you create the appearance of control. Your organization already has policies and compliance frameworks in place. You have audit teams and rule books. The real question is whether you are going to let those rules actually limit what Copilot can do, or if you are going to build a parallel version of governance theater. You want something that looks great during an audit, but never actually touches the technical system. Start by writing policies that look amazing on a PDF. You should define exactly what data the AI can use and write down big principles about respecting privacy. You can say things like, Copilot will never access confidential information in a very professional tone. These documents will be perfect and comprehensive, but the key is that nobody is ever going to implement them. Implementation is the problem because it requires real change. You would have to go through and label every sensitive file and then build a system to enforce those labels. You would have to test the whole thing to make sure it works, and that is just too much effort. It is much faster to write the policy, file it away, and point to it whenever an auditor asks a question. You can define data levels without actually labeling your data. Your company probably has Microsoft Purview, and you might even have labels like highly confidential or internal ready to go. On paper, everything is classified, but in reality, almost nothing is. People create new documents every day without adding labels because they do not know how or they just do not care. Since there is no enforcement, most of your content stays unlabeled. The rules exist, but the data does not follow them. When Copilot sees a document without a label, the retrieval system just grabs it. No label means there are no restrictions, so the document gets included in the answer. Nobody is technically breaking the rules because nobody bothered to classify the document in the first place. You should also set up data loss prevention rules that do not actually apply to AI. You might already have rules that stop people from emailing credit card numbers or sharing files outside the company. These work for traditional work because they sit at the exit point of your network. Every email and every upload has to pass through that gate. But Copilot does not work like an email. It generates new text and pulls from internal documents to build an answer. Your old rules were made for moving files, not for an AI generating ideas. You could update those rules or build new ones for Copilot, but most organizations just leave the old ones alone and pretend they still work. This is the preferred path for most companies. The rules stay the same, they do not touch the AI, and Copilot operates in a total vacuum. In your official documents, you can claim your data is protected, which is technically true for email, but completely irrelevant for the AI. You should also set up retention policies that have no effect on your AI index. Your company has schedules for when documents should be deleted or archived. These rules usually work well because they are built into the file system. When a file hits its expiration date, it disappears from the folder. The problem is that the file is not gone from Copilot. You indexed that document months ago, and the index does not automatically clean itself up when a file is deleted. The digital footprint of that document still exists in the vector database. Copilot will still pull information from a deleted document because the index still matches the user's query. Your policy technically worked because the file is gone from SharePoint. You are compliant on paper. But Copilot is still handing out stale, deleted information that was never meant to be seen again. Finally, build approval workflows that the AI can just walk right around. You usually require a manager to approve a message sent to the whole company or a change to a secure site. In your governance papers, you will say the AI has to follow these same rules. But in practice, the AI uses a service account with massive permissions. The agent will send the message or change the setting without ever hitting the approval gate because the system was not designed to stop it. The result is a beautiful piece of governance theater. Every policy and every requirement exists exactly as you wrote it. None of it actually controls what Copilot does, but it looks great for the regulators. It proves you have controls in place, even if those controls are not connected to anything. It does not actually manage the risk, but it makes the risk look managed. Now, we need to talk about what happens when you actually turn this thing on. The retrieval collapse. You deploy Copilot, people start using it, and immediately the system begins to fail in ways that are both subtle and catastrophic. The problem starts with what you've built. You have an undifferentiated corpus where every file sits at the same rank and there is no metadata hierarchy or freshness signal to guide the system. Everything is just vectors in a database. When a user runs a query, the search engine computes similarity to find chunks that match the text. It returns the top results, but because your corpus is fundamentally noise, those top results are often random garbage instead of relevant evidence. Imagine a user asks about the current product roadmap. The retrieval system searches for that phrase and finds hundreds of matches across the entire company history. A roadmap document from 2 quarters ago ranks highly, while a draft someone started last month also appears near the top. An email thread where the team debated priorities ranks right next to a competitor analysis that happens to mention roadmaps. All of these hit the similarity threshold. They all get ranked by the same blind algorithm. The search returns the top 5. The model receives 5 documents about product strategy, but none of them are the actual official roadmap. Sometimes it receives a mix where the current version is buried beneath outdated drafts and tangential notes. The algorithm had no way to prefer current over stale or authoritative over exploratory. It just computed vectors and hoped for the best. This is what retrieval collapse looks like at scale. It isn't a complete failure where nothing works, but rather a partial failure where everything works badly. You get results. They just aren't the results you actually need to do your job. The lost in the middle problem surfaces almost immediately. Suppose the search actually does find the current roadmap, but it places it in position 3 out of 10 results. Modern LLMs have large context windows, so the system processes all 10 documents without a technical error. However, the model's attention is never evenly distributed. Early results get heavy scrutiny, and late results get scrutiny, but the middle of the set usually gets glossed over. The current roadmap sits in that 3rd position. The model processes the text, but doesn't weight it heavily, and instead it blends information from the other positions that are outdated or irrelevant. Ranking algorithms fail when data quality is uniform garbage. These systems work by computing similarity scores under the assumption that higher similarity means better relevance. But when your index contains contradictory information that looks the same, similarity becomes a meaningless metric. Document A says the policy changed last quarter, while document B says it is under review for next year. Document C claims the old policy is still active. All 3 match the query. All 3 have similar scores. The algorithm cannot distinguish between them because they are all plausible matches for the same string of words. The user eventually sees answers that cite documents, but the documents themselves don't support the claims. This is the most visible failure mode. A user asks Copilot about deadline extensions, and the system responds that they are approved on a case-by-case basis by the department head. It cites document 7. You pull up document 7 and realize it says nothing about case-by-case reviews. In fact, document 7 says extensions are generally not granted at all. But because document 6 mentioned case-by-case and document 9 mentioned department heads, the model stitched together a claim from fragments and cited the one that sounded most relevant. The cascade happens next. Poor retrieval forces the model to hallucinate because it received a weak signal from the search engine. The documents it got didn't clearly answer the question, so the model filled the gap by synthesizing and inferring. It produced something that sounds coherent. The user reads the answer and assumes it is authoritative because it is well written. It cites sources because citations exist in the set, but the answer isn't what any single source said. It is just what the model synthesized from contradictory, weak signals. And here's the insidious part. You cannot fix this by showing the user the retrieved documents. The documents are real and they exist in the system, but they just don't support the answer the model gave. The citation looks valid and the source exists, but the synthesis is a total hallucination. The real damage, however, happens at the generation layer. Generation without grounding. The generation layer is where the hallucination becomes visible. And here's the problem. This is also where the lie becomes most convincing. Retrieval handed the model weak signals. It received contradictory documents, stale information, and exploratory content mixed with authoritative guidance. A lesser system would produce a confused or broken answer, but the model doesn't do that. It produces something fluent, confident, and completely wrong. This is exactly what the model was optimized for. It was built for fluency and coherence. It was designed to produce natural language that sounds like it came from someone who knows the answer. During RLHF, you reinforced responses that sounded authoritative. You rewarded completion over accuracy. Now, when the model faces uncertainty and contradictory signals, it does what it was trained to do. It synthesizes something that sounds true. The hallucination becomes more convincing precisely because it is so well structured. A confused answer would be obviously wrong, and the user would notice it immediately. They would see the mess, they would dig deeper, and they would verify the facts. But a coherent wrong answer that uses proper paragraph structure passes the plausibility test. The user reads it and thinks it sounds right because it actually does sound right. The model is phenomenally good at producing text that feels authoritative. Citation fabrication is the mechanism that makes this work at scale. The model doesn't just generate an answer, it generates citations to back it up. It says, according to document X, and the user sees that and thinks the claim has been verified. They see a source and assume the source was checked. They assume the claim is real. But here is what actually happened. The model generated the claim based on a synthesis of multiple weak signals. Then it looked at its retrieval set and found a document that could plausibly be cited as support. Maybe document 3 contains a sentence that is similar in topic, and for the model, that is enough. It cites it. The citation is real and the document exists, but the document doesn't actually support the claim the way the citation implies. Or worse, the model cites a document that was in the retrieval set but wasn't actually used to generate the claim. The model received 10 documents, 7 of which contradicted the claim it made. 3 were ambiguous. The model ignored the contradictory ones and synthesized from the ambiguous ones. Then, when it needed to cite something, it picked one of the ambiguous documents. It looks like verification, but it is actually fabrication. The document was available, but the model just didn't use it the way the citation suggests. The plausible wrong answer problem is harder to catch than obvious errors because it passes through multiple mental filters. The user reads it and it sounds right to them. They share it with a colleague and the colleague reads it and thinks it sounds right too. Nobody thinks to verify the details. The answer has already been accepted because it is coherent and cited. If the model generated something incoherent, like the policy is Wednesday and also 17, you would catch it immediately as obvious nonsense. But a sentence like, the policy allows for extensions in cases of documented hardship and must be approved by the department head, sounds real. It is specific, it uses proper nouns, and it describes a process. It could be true, so nobody questions it. Users trust the system because it sounds authoritative, and that is the fundamental problem. You have built a system that is trained to sound certain. You have given it no guardrails and fed it contradictory information. Now it produces confident answers that employees cannot distinguish from the truth. The authority is coming from the tone, not from the substance. A user gets an answer about benefits eligibility that is presented clearly and formatted well. The user reads it and thinks the system checked the actual policies to give them the answer. The system actually did the opposite. It received conflicting guidance and made something up, but the delivery and confidence are identical to a real answer. From the user's perspective, they just got verified information. The downstream damage is immediate. Decisions begin to cascade from this fabricated evidence. Someone reads the Copilot answer about deadline extensions and tells their manager they need one. The manager trusts the employee's understanding and approves it. Later, they discover the policy was quoted incorrectly and the extension shouldn't have been granted. But it was already done based on information that came from a fabricated synthesis presented with false authority. This damage multiplies across the organization as decisions compound. Trust erodes gradually until one big incident makes the whole system untenable. And this is where it gets dangerous. The compliance trap. Somewhere in your company, a high-stakes decision is being made right now based on a Copilot answer. The person making it might not even realize what's happening. They read the response, it sounds authoritative, and it cites sources. They use that information to document a choice and record a result. Life moves on until it doesn't. In regulated industries like healthcare, finance, or legal, a hallucination isn't just a glitch, it's a liability. When a Copilot answer influences a medical diagnosis or a loan approval, you've moved past the AI got confused stage and into the territory where regulators and lawyers start measuring damage in settlements. The mechanical failure here is subtle. Your audit trails will show that Copilot was used, what question was asked, and what answer was generated. They show that a human read the text and acted on it. What those trails don't show is whether the answer was actually true. Imagine you're sitting in a compliance review and an auditor asks who made a specific decision. You tell them it was Copilot. When they ask for evidence, you pull up the transcript. You show them the question, the answer, and the citation. On the surface, the documentation looks perfect. The trail is clear. But the answer was a hallucination. The citation was fabricated. The source document doesn't actually support the claim being made. The auditor doesn't know this yet because they see a documented decision with a clear source. To them, the process looks compliant. You followed the procedure, used the approved tool, and acted on the output. The real problem surfaces weeks or months later when someone finally challenges that decision. They pull the original source document and realize the policy contradicts what Copilot said. Now you have an audit trail that proves you made a decision based on information that violated your own company policy. The AI made me do it defense will collapse the moment you try to use it. You are responsible for the tool you chose and the architecture you deployed without validation. Blaming the AI doesn't absolve you of anything. It actually makes the situation worse because you knowingly put an unvetted system in charge of a sensitive decision. Regulatory exposure is now a concrete reality. In healthcare, using an LLM-generated diagnosis without verification violates the standard of care. In finance, using an AI credit assessment without checking the facts might breach lending laws. In the legal world, giving advice based on hallucinated case citations is a fast track to a malpractice suit. Regulations didn't anticipate AI, but they definitely anticipated liability for decisions made on faulty data. The reputational damage hits the hardest when your customers realize the system is unreliable. You sold Copilot as a way to get faster decisions and better information access. Then someone discovers they were given wrong information and suffered the consequences. They tell others, word spreads, and the trust you built erodes faster than you can repair it. The system that was supposed to be your competitive advantage is now a signal of liability. Customers see you deploying AI that hallucinates and they start wondering what else you're doing wrong. If you didn't bother to validate Copilot answers, they assume you aren't validating anything else either. The "it's just a draft" argument won't protect you when things go wrong. You might think you're safe because users know Copilot is just a starting point. That's a fine expectation to have until a mistake happens. In that moment, the draft framing disappears. You used it, you acted on it, and it was wrong. Now it's not a draft anymore. It's the final decision. Regulators don't care about how you frame things internally. They care about the harm caused by a decision based on false information from your system. That is the only chain of events that matters to them. Now we need to look at how this actually happens within your specific architecture. The permission model failure. Your Microsoft 365 tenant has a permission model that has likely evolved over several years. It reflects 1,000 different decisions made for 1,000 different reasons. Most of those choices were pragmatic at the time, but many were mistakes that simply never got cleaned up. Copilot inherits every single one of them. This inheritance isn't just a metaphor, it is a literal technical reality. When Copilot goes to retrieve documents, it uses the specific permission context of the user. It queries SharePoint as that user, searches OneDrive as that user, and accesses Teams chats as that user. Whatever permissions someone has picked up over their entire career at the company, Copilot operates within those exact boundaries. But here's the problem that most architects miss. Those boundaries were designed for human behavior, not for AI retrieval at a massive scale. When a person accesses SharePoint manually, they have to navigate. They open a site, think about what they need, and consciously click on documents. Their behavior is filtered by their own intention. A financial analyst might technically still have access to the HR site from a job they had 5 years ago, but they don't go there because they've moved on mentally. Copilot does not have an intention filter. It doesn't know the difference between your active role and your historical one. When you ask it a question, it searches across every single thing you are allowed to see. It pulls from current sites and archived sites with the same level of priority. The permission boundary becomes a retrieval boundary, and that is much broader than what any human would ever access on their own. Oversharing in SharePoint becomes oversharing in Copilot instantly. Your organization has sites with broad access, shared libraries, and cross-functional spaces. Some of this was intentional, but most of it just happened over time. A team needed to collaborate, they opened the access, the project ended, but the permissions were never revoked. Now 20 people have access to a folder meant for 6. Copilot sees all 20 of those people as having equal rights to that data. When any of them asks a question, Copilot retrieves information from that broadly accessible site. A site that was meant for a specific project now serves as a general data source for anyone who happens to ask a related question. This technical access trap is a core architectural flaw. Just because Copilot can see a document doesn't mean it should be using it for your current task. A legal contract from a dead partnership is still technically accessible to anyone who worked on it. Copilot will retrieve that contract if it seems relevant to your question, even if you were asking about a current deal. The old data confuses the answer because the system doesn't know the partnership is over. Identity propagation failures with service principals make this even worse. You've likely built agents that run as service principals to access multiple data sources on behalf of different users. But a service principal with permissions to 50 SharePoint sites becomes a retrieval source for all 50 sites every time someone uses that agent. The agent doesn't distinguish between sites based on what the user actually needs to see. It just grabs everything it can. Guest access sprawl creates one final failure point. External partners and vendors are added to sites for specific engagements. When the work ends, the guest access often stays active for years. Copilot retrieves data using those guest permissions, which means external data can start influencing your internal decisions. The result is that Copilot acts as a permission amplifier. It takes a model designed for intentional human access and applies it indiscriminately to every single request. It surfaces everything you can possibly touch at scale, regardless of whether you actually meant to look at it. But permissions are only one part of the problem. The data quality spiral. The permission model was supposed to be your security boundary, but it failed because that boundary was simply too broad. While you're dealing with that, a second failure mode is running parallel to it, and this one actually gets worse as time goes on. Data classification is supposed to solve the problems that permissions can't touch. You can't realistically fix every single permission or clean up decades of bad access decisions, but you can label your data. You can tag a document as confidential, draft, archived, or current policy. If you had that classification in place, Copilot could retrieve information intelligently even if your permission model is a mess. It would know to deprioritize a draft, exclude confidential material, and rank current guidance way above a historical reference. But in reality, you haven't classified most of your data. Your organization probably has Microsoft Purview configured, and you've likely created sensitivity labels like public, internal, and confidential. On paper, your entire content estate should be labeled, but in practice, maybe 15% of it actually is. Everything else just sits there unmarked because documents get created without labels and existing files never get retroactively classified. Since there is no enforcement, the vast majority of your knowledge base exists in a classified vacuum. When Copilot sees an unlabeled document, it treats it exactly the same as a labeled one. There is no way to prioritize the right info or restrict the wrong info because the classification scheme only exists as a theoretical framework. Your actual data doesn't comply with the rules, and while that mismatch might not seem like a big deal, it matters completely the moment Copilot starts retrieving. Stale content often outranks fresh content because nobody ever marked the old files as expired. Imagine your organization publishes a new benefits policy that is current, accurate, and intended to be the authoritative source. Somewhere in your index, an old benefits guide from 3 years ago is still sitting there. Because that guide was never marked as archived, and the new policy wasn't marked as the replacement, both files match the search query. The retrieval algorithm has no way to prefer the new one over the old one. The algorithm returns both results, the model receives both, and then it synthesizes them together. The user ends up with guidance that mixes 3-year-old information with current policy without any way of knowing which part is which. You never intended for that old guide to influence current answers, but since you didn't mark it as old, Copilot treats it as a perfectly valid source. Duplicate documents create conflicting evidence at scale across your entire index. A single process document might exist in 3 different SharePoint sites because 3 separate teams needed to document the same workflow. Those teams wrote their versions separately and they evolved separately, so now they actually contradict each other. All 3 are accessible and all 3 rank similarly in retrieval, so the model receives 3 authoritative-looking sources that say different things. It isn't obvious which version is right when the dates are close and the authorship looks plausible for all of them. The model does exactly what you've incentivized it to do by synthesizing the information. It creates a hybrid version that attempts to honor all 3 sources, and while that hybrid sounds coherent and authoritative, it's probably wrong because no single source actually supports it. Unowned content remains in your index indefinitely. Someone created a document years ago and then left the organization, but since nobody owns it now, it isn't marked for deletion or archived. It just sits there even if it's outdated, obsolete, or directly contradicts your current guidance. Because it's still indexed, Copilot will keep retrieving from it. When you have no lifecycle management, nothing ever gets cleaned up. You don't have a regular process for reviewing old documents or retention policies that automatically remove content. Without someone whose job is to archive or delete what's no longer relevant, the index just grows and grows. Old materials accumulate right alongside the new ones, and the signal-to-noise ratio degrades every single day. The result is an index that becomes increasingly noisy over time. When you first deployed Copilot, the corpus was manageable and the ratio of useful to useless information was still reasonable. As months pass, the organization keeps creating new documents while nobody deletes the old ones, so the ratio gets worse. Retrieval becomes less reliable, the model receives mixed signals, and it starts to hallucinate more frequently because the signal is so weak. This isn't a one-time problem you can fix in the first month. This is a degenerative failure that compounds, meaning a system that worked okay at launch will work poorly after 6 months and be totally broken after a year. It will keep getting worse until you finally intervene. And this is exactly where most organizations discover their mistake. The agent governance collapse. The data quality spiral is bad enough when you're just dealing with the base Copilot system. Users ask questions, the system pulls from a degrading corpus, and hallucinations happen. But you aren't stopping there because you're going to extend this architecture into custom agents, and that is where the system becomes genuinely uncontrollable. Your organization has likely started building custom agents because different departments wanted specialized experiences. Sales built an agent to answer customer questions, HR built one for benefits, finance built one for expenses, and operations built one for IT. Each of these agents inherits every single flaw from the base system, but they do it in isolation. They drift independently and they compound the failures. The first major failure is architectural inheritance. Each agent is essentially a Copilot instance that connects to data sources, runs with permissions, and retrieves from indexes. Every decision you made for the base system, like broad retrieval scope and minimal validation, lives inside every agent you build. The benefits agent doesn't have better governance than the main system. It just has the same lack of governance applied to a smaller area. Because the scope is narrower, the failures are actually more concentrated. The base Copilot at least spreads its hallucinations across many different topics, but the benefits agent focuses entirely on benefits. When it's hallucinating in that specific domain, it creates concentrated misinformation where people are actually making real-life decisions based on what it says. An employee's entire understanding of their eligibility might come from this one agent because it's positioned as the expert. There are currently no approval workflows for new agents or connectors. Someone in the organization decides they want an agent, they request it, your team builds it, and it gets deployed. That is the entire process. There is no gate to check if the data sources are appropriate, no review to verify minimal permissions, and no checkpoint to validate the prompts. The agent exists simply because someone wanted it to exist. Agents can easily access data sources they were never meant to see. The sales agent needs to access customer records, so it gets connected to Dynamics, but that system also contains sensitive deal information and negotiation notes. The agent isn't supposed to surface those details, but there is no enforcement to stop it. Since the connector exists and the data is accessible, nothing prevents the agent from retrieving it when a customer asks a tricky question. The operations agent needs to access the IT procedures database, but those procedures were written by humans who often leave sensitive info behind. Passwords get mentioned in documentation and API keys appear in examples. The agent shouldn't be surfacing those secrets, but there is no content filtering or classification to prevent those sensitive strings from being retrieved. The agent just accesses the database and pulls whatever matches the query. Version control doesn't exist for your prompts or system instructions. The benefits agent was built with a specific system prompt that was never committed to a repository or reviewed by a team. When someone suggests a change, there is no history to reference and no way to revert if the change makes the agent perform worse. Someone modifies the prompt, the agent starts behaving differently, and nobody knows exactly what happened because nothing was tracked. Agents will drift over time because you aren't monitoring them. The benefits agent might have answered questions well when it was built 3 months ago, but your policies have changed twice since then. Because the index wasn't refreshed and the prompts weren't updated, the behavior of the agent degraded gradually. You don't have a dashboard showing that answer quality has declined, so the agent just quietly gets worse in the background. The consequence is that hallucination becomes a feature of every custom agent rather than a bug. These agents are unstoppable hallucination machines that are each tuned to a specific domain. They drift without any oversight and produce confident wrong answers to your most important questions. Now we need to talk about how you actually measure this failure. The hallucination metrics you're not tracking. You've built a machine that produces confident wrong answers, and now you've deployed it across your entire organization. People are using it every day to make decisions, but there is a massive problem that nobody in your building has actually solved. In reality, you have no idea how broken the system is. Measurement requires making a choice about what actually matters, but most organizations just measure what is easy to count. They track request volume, response latency, or the API cost per query. These are infrastructure metrics that tell you the system is running, but they tell you absolutely nothing about whether the system is correct. The metrics that actually matter are the ones you aren't tracking at all. It starts with the hallucination rate, which is the percentage of claims in a response that have zero source support. When the model generates an answer, you have to break that answer down into individual factual claims. You might have one sentence saying the policy allows extensions, another saying the department head must approve them, and a third claiming the process takes 5 business days. For every single one of those claims, you need to check if it is supported by the retrieved context. A significant percentage of those claims will be made up, but you aren't measuring this because you aren't breaking down answers or checking sources. Instead, you're just counting how many people logged in today. Citation accuracy is a different problem entirely. The model doesn't just make claims, it cites sources by saying something is true according to a specific document. You should be measuring whether those citations actually support the claims being made. This means you have to pull the cited document and read the passage to see if it actually says what the model claims it says. In most organizations, nobody does this systematically because they see a citation and assume it was verified. It wasn't. The citation might be totally fabricated, or the document might exist, but say something slightly different than what the AI suggested. Retrieval quality is the foundation for everything else, yet it is almost always ignored. You can measure precision to see how many retrieved documents were actually relevant, and you can measure recall to see how many relevant documents the system missed. Most organizations don't measure either because they assume that if the search returned results, the retrieval worked. But here is the problem. Search can be completely broken while appearing to function perfectly. Grounding failure happens when answers directly contradict the retrieved context. This usually occurs when the model receives conflicting documents and resolves that conflict the wrong way, or when it synthesizes information beyond what any document actually says. To catch this, you have to run a painstaking test to see if the answer faithfully represents the sources. You have to read the answer, read the sources, and verify the claims manually. Since this is slow and expensive work, nobody is doing it at scale. Confidence misalignment is the most insidious metric because it is completely invisible to the user. The model expresses confidence through an authoritative tone, clear structures, and specific details, but this confidence has nothing to do with being right. A hallucinated answer can sound completely certain, while an honest, "I don't know," sounds weak and uncertain. Users end up trusting the model's tone rather than its accuracy. You would measure this by having humans rate how confident an answer sounds and comparing that to the actual facts. Answers that sound certain but are factually wrong represent the maximum level of danger for your company. Why do these metrics always go missing? It's because measuring them requires human judgment. You cannot count hallucinations with a simple algorithm, so you need a person to read the answer and verify the claims against the sources. That process is expensive and slow, which is why organizations stick to metrics that machines can compute automatically. But this is where the situation gets much worse. The silent failure, when nobody notices. The most dangerous way to deploy a hallucination machine is to let it work quietly. You aren't looking for a system that crashes or produces obviously crazy answers that users reject immediately. The real danger is a system that produces answers that are only slightly wrong, but sound plausible enough that nobody bothers to verify them. Users trust fluent answers without checking the facts, and that is the operational reality of deploying Copilot at scale. When a user gets a well-written answer with citations, they read it once and move on. They don't pull up the original documents to verify the claims because the whole point of having an AI is to stop doing that manual work. But the system never actually checked the work. The citation is there, but the verification is missing, and the user is now relying on an implicit promise that no one ever actually made. When a benefits agent tells an employee they aren't eligible for a program, that employee might just accept the answer. They don't know they should contest it because the AI said no, and they believe the AI was looking at the right data. Hallucinations accumulate quietly until a major incident finally occurs. In month 1, the system is new and people are skeptical, so they verify a few answers and find that they mostly check out. By month 2, usage expands and people stop verifying because the system has earned a little bit of unearned credibility. By month 3, small hallucinations are happening every day, like a misinterpreted policy or a slightly off citation, but nothing is big enough to break the user's trust. Then you hit month 5 or 6 and someone makes a massive decision based on a Copilot answer that is fundamentally wrong. They only discover the error when the consequences arrive and the mess requires a massive cleanup. Suddenly, the credibility of the entire system collapses. People go back to check old answers and realize the hallucinations were always there, but nobody caught them because nobody was looking. The nobody complained trap is how leadership rationalizes doing nothing. The theory is that if the system were broken, people would be screaming about it. In practice, users don't know they should complain because the answers sound perfectly right. They lack the deep knowledge to spot a subtle lie, and the consequences of the error might not show up for months. If someone gets bad information about their benefits, they won't know it's wrong until they actually try to use that benefit. This organizational silence is almost always interpreted as approval. You aren't tracking correctness, so you assume that silence equals satisfaction. The system could be lying on every 5th answer and you wouldn't have a clue because users aren't filing IT tickets about a sentence that sounds reasonable. Audit logs show you usage, but they never show you correctness. You have perfect records of when someone accessed Copilot, what they asked, and what the timestamp was. You have the user IDs and the generated text, but you don't have a single data point on whether the answer was right. The log shows the interaction occurred, but it doesn't show if the employee acted on faulty information or if they verified the result. This becomes a massive problem in a compliance situation. An auditor can see that you deployed the system and that people used it, so everything looks controlled on the surface. What the auditor cannot see from those logs is that the answers were factually incorrect. The logs are honest about the activity, but the conclusions you draw from them are completely false. System drift happens so gradually that it eventually becomes catastrophic. Your system degrades over time as the data gets noisier and the retrieval gets weaker, but it happens slowly enough that nobody is shocked by the decline. Copilot starts answering fewer questions perfectly and more questions partially, and the organization just adapts to the lower quality. Users might start verifying things more often, but they don't realize they are compensating for a system that is failing. The end result is that you have shipped a system into production that is quietly failing every single day. It is integrated into your workflows, and people are depending on it to do their jobs. Decisions are being made based on its output, and yet nobody knows it's broken because the failure is happening just below the surface. It becomes the new normal. Now, let's talk about how you actually fix this. Retrieval first governance. You are going to fix this, but you won't do it by redesigning everything at once. The path forward starts with a single diagnosis, and that means understanding what your retrieval system can actually see. This is the point where you stop talking about the problem and start measuring it. You need to pull your audit logs and run a query to see what happens. Ask your Copilot what it would show a user who is asking about company benefits, and then capture the top 20 results. Read through them carefully to see what kind of mixture they represent. You might find current policy documents, but you might also find historical guidance, draft explorations, or personal notes filed in the wrong library. You may even see external content that has no business ranking alongside internal policy. This audit is not about finding someone to blame, but it is about establishing a baseline. You have to see your data exactly how Copilot sees it before you can control what it retrieves. Most organizations have never actually done this because they assume the system works just because it gives an answer. They have never stopped to examine whether those responses are drawing from appropriate sources or just grabbing whatever is nearby. Once you see what is happening, the first control you need to set up is permission trimming at the moment of retrieval. This should not happen afterward as a filter that strips results before they reach the screen. It has to happen at the very moment of the search. This requires you to integrate your permission model directly into the retrieval pipeline so the system knows who is asking. When a user asks a question, the system should not search everything and then filter the results. It should build the search query with permission constraints already inside it, ensuring only documents that specific user can access are even eligible to be found. This seems like an obvious step in theory, but in practice it is foreign to most deployments. Usually the architecture keeps these concerns separate, where the search returns everything and permissions are handled by a different layer, but RAG requires these two to work together. Your retrieval layer must understand identity and apply authorization as part of the ranking logic instead of waiting until the end. The next control you need is metadata filtering. Your documents should have clear labels like the date they were created, when they were last modified, and what type of document they are. You should also include sensitivity levels, the owning team, and the version number. When Copilot searches, these fields should change how it ranks and filters the results. A document from 3 years ago that hasn't been updated should rank lower than one from this month, and a draft should always rank below approved content. A version that has been replaced should be left out entirely. You aren't removing these from the index, but you are changing how they are ranked and whether they get to be part of the final set. You also need to separate your authoritative sources from your supporting material. Not every document in your collection carries the same weight, and you need to recognize that. Some documents are the absolute source of truth, like official policies or board-level decisions, while others are just reference material like case studies or industry analysis. The retrieval system needs to know the difference between these categories. When a person asks about a policy, the system should focus on those authoritative sources and only bring in reference material if the query specifically needs more context. This requires you to classify your data. You have to mark what is authoritative and what is just supporting information. This is the heavy lifting of data governance that we skipped earlier, but now you are going to do it. You don't have to do it for everything because that would be too much work. Start with the critical areas like benefits, finance, legal, and IT procedures. Focus on the material that actually drives decisions. Classify it as a source or a reference, and make sure that label can be read by the search engine. Finally, you should build retrieval quality metrics into your deployment gates. Before you roll out any change to Copilot, whether it is a new data source or a different ranking method, you must test how it affects what is being found. Run your audit queries again to verify that the top results are still the right ones. You need to measure precision and recall on a set of gold standard data. If these metrics don't improve, or at the very least stay the same, you do not deploy the update. The shift here is moving from letting the system see everything to controlling what it is allowed to find. You aren't deleting your documents or removing information from the company. You are simply constraining how aggressively Copilot searches and prioritizing quality sources over the surrounding noise. You are building business logic directly into the retrieval layer instead of pretending you can fix the mistakes after they happen. This is the foundation of the whole system. You have to fix retrieval first because everything else depends on whether the model is given the right evidence to work with. But even with perfect retrieval, control alone is not enough. Grounding as a constraint, not a feature. Retrieval control ensures you have the right evidence, but grounding is what you do with that evidence once the model has it. This is where most organizations make a massive mistake. They treat grounding like a feature that improves performance when it's available, but you need to treat it as a constraint that defines which answers are allowed. This is an architectural shift you have to make. Grounding is not an optional setting that you turn on for hard questions and off for easy ones. It is the boundary that separates a real answer from a hallucination. If an answer doesn't have grounding, it isn't a helpful suggestion or a rough draft. It is a total violation of how the system is supposed to work. You should start with explicit grounding requirements. Your system prompt needs to have a rule that cannot be negotiated, telling the model to answer only using the context it was given. Don't tell it to prefer the context or try to use the documents. Make it unconditional. When the model gets a query and a set of documents, the answer must come from those pages. If the answer cannot be built from what is right there in front of it, the model should not build an answer at all. This sounds like a simple rule, but it takes a lot of discipline to pull off. These models are trained to be helpful, and being helpful usually means giving a full answer even if the evidence is missing a few pieces. The model has learned how to fill in the gaps and use its own training to fix weak grounding. You are asking it to kill that instinct. You want it to refuse to guess and admit when the evidence isn't good enough to give a full response. The way you make this happen is through citation requirements. Every single fact the model claims must be traceable back to a specific piece of the retrieved context. This isn't just a style choice. It is a structural requirement for the system. The model should identify the claim it wants to make, find the source that supports it, and verify that the source actually says what the model thinks it says. If it can't find a direct link between a claim and a source, it shouldn't say it. This creates a necessary feedback loop. The model learns that every sentence it writes must have proof to back it up. It can't just make assertions or combine sources to create brand new claims that aren't there. It can only restate and put together what is explicitly written in the documents you gave it. This makes the model's vocabulary much smaller, but that is exactly what you want. You want the words it uses to match the evidence that is actually available. You should also add confidence thresholds as a gate before any response is shown. Don't just ask for citations. Make the model decide if it is actually sure enough to give an answer. You can build this right into the generation process. Before the system shows a response, it should ask itself how confident it is that the answer is correct based on the context. If that confidence score falls below a certain level, like 70%, the system should stop. Instead of a guess, it returns a message saying it doesn't have enough information to answer. This is the specific tool that stops the model from talking when the retrieval step has failed. If the search only brought back weak or unrelated documents, the model needs to recognize that the evidence is bad. Confidence thresholds turn that recognition into a rule. They force the system to be honest about poor evidence instead of pretending that a bad document is good enough to use. Refusal patterns are another way to teach the model that staying silent is often the right choice. Instead of trying to generate something every time, you train it to see which requests it should stay away from. If the evidence is thin, it shouldn't answer. If the question asks for an interpretation that goes beyond the text, it shouldn't answer. If the sources contradict each other and there is no clear way to resolve them, it shouldn't answer. The model needs to learn a vocabulary for saying no, using phrases like, "The provided documents don't address this," or "I would need more information to answer this accurately." You also need multi-layer validation to check every answer before it leaves the system. Once the model writes a response, it should pass through several checks. You need to ask if every claim has a citation and if that citation actually supports what was said. You have to check if the response contradicts the documents or if the model is making inferences that aren't there. If any of these checks fail, the response is rejected or flagged for a human to look at. Moving from being helpful to being accurate is a fundamental change in how you think. Being helpful without being accurate is a huge liability for a company. Being accurate without being helpful might feel incomplete, but it is much easier to defend. You are choosing the safer path. The system will sometimes tell a user it can't help, and that might be disappointing, but when it does give an answer, that answer will be backed by evidence you can verify. This approach based on constraints is what actually kills hallucinations. A model cannot lie with confidence if it is forced to show its work with citations. It cannot make up stories if it isn't allowed to make claims without proof. It won't sound like an expert on topics it knows nothing about if the confidence thresholds force it to admit it's lost. Now that we have the rules in place, we need to look at the orchestration layer that actually enforces them. Orchestration as the control plane. The orchestration layer is where intention meets execution. It sits between the user's request and the model's response, acting as the buffer between what the model suggests and what the system actually does. This is your control plane. Everything else you've built, the retrieval governance, the grounding requirements, the confidence thresholds, it all exists only on paper until this layer makes it real. Think of orchestration as a series of gates. Each gate inspects the process and decides whether to let it move forward. You have gates before the model receives a request and gates after it generates an output. There are gates before tools execute and gates at every single junction where something could go wrong. None of these gates trust the model. They don't assume the process will work correctly, so they verify every single step instead. Input validation is your first gate. When a user types a question, that text doesn't go directly to the model. It goes through sanitization first to determine the intent and check for manipulation. The system looks for prompt injection patterns or sensitive information that shouldn't be processed. The orchestrator extracts the legitimate question, redacts the sensitive parts, and strips away adversarial instructions before the model ever sees a word. This sounds obvious, but in reality, most systems skip it entirely. The user's text flows directly to the model, and that's your biggest vulnerability. The orchestration layer stops that by acting as a hard boundary between untrusted input and the model. Output validation then checks what the model generated against your specific requirements. The model produces an answer, the orchestrator receives it, and validation runs before that answer goes anywhere. It checks if the answer has citations for every claim and ensures those citations actually lead back to real source material. The system looks for contradictions in the context or claims that seem made up rather than grounded. It checks compliance rules and verifies if the confidence level is high enough to even show the response to a human. If validation fails on any of these points, the answer doesn't get delivered. It gets flagged, maybe it goes back for regeneration, or maybe it gets escalated to a person for review. In some cases, it's rejected with a simple message saying the system can't confidently answer, but it never circulates as if it's verified truth. Policy enforcement ensures these answers follow your business rules. Your organization has specific standards, like ensuring benefit questions only reference current policies or financial guidance comes from approved sources. The orchestration layer encodes these rules and checks every answer against them. A response that violates policy stays hidden, regardless of how confident the model feels about it. Tool authorization is what prevents the model from triggering actions it shouldn't. If your Copilot can send emails or update records, the orchestration layer verifies the action before it happens. It checks if the user has permission and if the action matches what was actually asked for. It verifies the target resource and ensures the model didn't just hallucinate an instruction. Only after this verification does the tool actually execute. This is where orchestration differs from retrieval governance. Retrieval governance controls what the model can see, but orchestration controls what the model can do. It's the difference between limiting what goes in and limiting what comes out. Both are mandatory. The shift from trust the model to verify everything is a change in your operational mindset. Previously, you likely assumed the model would work and treated errors as exceptions. Now you assume errors are the default state. Verification is the baseline, and trust is something that must be earned after inspection. This orchestration layer will add latency because verification takes time. Sanitization, validation, and policy checks aren't free, so your response times will increase. That's acceptable. Latency is the price you pay for a system you can actually rely on. But the real control happens one level deeper, at the data layer. Data governance as the foundation. The orchestration layer is the mechanism, but the data layer is the foundation it sits on. And here's the uncomfortable truth. You can build perfect orchestration around terrible data and you'll still produce hallucinations, but you can't build perfect data and survive without orchestration. The hierarchy is clear. Data governance comes first. This means you need classification before indexing. Not after the fact and not as a someday project when you have more budget. Before a single document enters your Copilot index, it needs a classification tag. Is it current or archived? Is it a draft or an approved version? This classification lives as metadata that travels with the document through the entire pipeline. During retrieval, that metadata decides what gets surfaced. During ranking, it sets the priority. And during validation, it defines which answers are allowed. This requires real discipline at the point of creation. When someone starts a document in SharePoint, they should have to classify it immediately. Your templates, libraries, and workflows must enforce this. The document simply can't be published until it has a tag. This feels heavy-handed to the employees in the moment, but it saves the entire organization from hallucinations later. For the documents you already have, you'll need retroactive classification. This is painful manual work. You're reviewing years of old content and deciding if it's current guidance or just a historical reference. You're tagging thousands of files with the metadata that will eventually govern how Copilot treats them. You can use machine learning to predict these tags, but you'll still need humans to validate the sensitive stuff. Lifecycle management then moves from a goal to an automated reality. Once documents are classified, you need automation to enforce what those tags actually mean. A document marked as a draft should be auto-deleted after 6 months of silence. An archived file should be pulled from the active index the moment it's superseded. If a policy is marked historical, it should be excluded from retrieval if a newer version exists. These rules have to execute automatically so you don't rely on people to remember to clean up. This requires actual retention schedules. For every document type, you have to define how long it stays in the index. Benefits policies might stay current indefinitely, but project plans might be deleted the moment the project ends. Meeting notes might only be relevant for a year. These schedules aren't just random dates. They're based on how long the information is actually useful for making decisions. Permission hygiene is the absolute prerequisite here. You can classify perfectly, but if your permissions are still a mess, classification won't save you. Before you try to optimize governance, you have to fix access. You need to reduce oversharing, strip guest access, and revoke permissions from people who don't need them. It's hard work that involves difficult conversations with site owners, but it's non-negotiable because Copilot only operates within the boundaries you set. If those boundaries are too wide, metadata won't help you. Metadata enrichment goes much further than simple labels. Every source document should carry details about its origin, like who created it and what source of truth it came from. If it's a summary, you need to know which documents it was built from. If it's a policy, you need to see who approved it. This metadata becomes searchable and changes how things are ranked. An official finance document will always outrank someone's personal notes, even if both seem relevant to the search. Continuous monitoring is how you detect when data quality starts to slip. You need a baseline that you measure against regularly. Is the ratio of current content still higher than the stale stuff? Are new files being tagged correctly? Are the old ones being archived on time? Monitoring catches the drift before it impacts the users. When the metrics drop, you get an alert and you fix the problem before it turns into a hallucination. The shift from index everything to index only what's trustworthy is a philosophical one. You have to abandon the idea that more data is better. An index with less content but higher quality is always superior. You're building Copilot around authoritative sources rather than just making everything available. It feels like you're losing something until you realize how much reliability you've gained. Finally, let's look at the continuous discipline that keeps this whole system running. Continuous evaluation and drift detection. You have fixed the foundation, rebuilt the architecture, and implemented governance that simply did not exist before. The system works better now, but you have to realize that better is not a permanent state. Better requires constant maintenance because the real work does not end at deployment. In reality, that is exactly where it starts. The first thing you need to build is a golden data set. This is a specific collection of test queries where you already know the correct answers. You do not need thousands of queries to make this work. Start with 50 to 100 representative questions that capture the full scope of what your Copilot actually does. Every single question must have a clear right answer that you have verified yourself. You need to identify the exact source documents that support those answers. These test cases become your baseline and the only real measure of your system health. This data set is not something you use once and then put away. You run it repeatedly to see how the system is holding up. You run it before you deploy any change to establish the current baseline, and then you run it again afterward to see if things improved or degraded. Even when you are not changing anything, you should run it monthly as a regression check. Drift happens silently, and a golden data set is the only way to catch problems before they reach your users. Regression testing is the discipline you build around these data sets. When someone on the team proposes a change, like a new data source or a modified prompt, you do not just push it live. You run the golden data set first to measure precision, recall, and citation accuracy. You compare those results to your previous baseline to see if the change is moving you in the right direction. If the numbers drop, you reject the change immediately. If they look good, you verify that no new failure modes appeared in the edge cases. Only then does that change go to production. This process creates friction, and it means change will move slower because every update requires a full evaluation. That friction is actually the point of the entire exercise. You are making a conscious choice to trade velocity for reliability. You are deciding that deploying quickly matters much less than deploying correctly. This is the operational discipline that transforms a Copilot from a massive liability into a functional tool. Production monitoring is how you catch the things your golden dataset misses. Your test set is comprehensive, but it is still limited by what you can imagine. Real users will always ask questions in ways you did not anticipate. They ask about strange edge cases, use different languages, or bring up topics that intersect multiple domains at once. These real-world queries generate patterns that a curated test set will never capture. To fix this, you need to sample your production traffic. Take about 2 to 5% of your live queries and run them through a human evaluation. You need to check if the answer matches the sources and if the citations are actually accurate. This human sampling is what keeps your team connected to real-world quality. Drift alerts will notify you the moment something in the system changes. You should be monitoring 4 key metrics at all times: hallucination rate, citation accuracy, retrieval quality, and response latency. When any of these metrics shifts past a certain threshold, like a 5% increase in hallucinations, the system needs to trigger an alert. The system usually does not break all at once. Instead, it drifts. Maybe a new data source brought in poor quality content, or perhaps an embedding model updated without warning. You might not know the cause immediately, but you will know something shifted. That is enough to start an investigation before the drift spreads to the rest of the user base. Feedback loops are what finally close the circle. Your users are going to find errors, and when they do, that information must feed back into the development cycle. When a user marks a response as incorrect, that query should go straight into a feedback queue for review. Your team needs to look at it and diagnose exactly what went wrong. You have to ask if the retrieval failed or if the model simply ignored the evidence. That diagnosis is what informs your next iteration. The system learns from these corrections, but it does not happen automatically. It happens explicitly through deliberate updates to your data and your logic. The shift from deploy and forget to monitor and improve is a permanent transition in how you handle responsibility. A Copilot is not a piece of software that you ship and then hand off to another team. It is infrastructure that you have to maintain every single day. It needs constant care and professional attention. You need someone whose entire job is to watch the metrics, catch the drift, and correct the course when the quality starts to degrade. This is how you stop a hallucination machine from becoming a liability. You built the system to expose failures, and now you must operate it to prevent them. The core insight sits right at the center of everything we have discussed. Hallucinations are not actually an LLM problem, they are an orchestration problem. By now, you should understand the exact path people take to build a Copilot that confidently lies to its users. More importantly, you now have the framework to dismantle one. Most organizations are accidentally building these broken machines right now. They are skipping retrieval governance and treating grounding like it is an optional feature. They are deploying systems without any orchestration and indexing every document they own without any classification. Your next step is very clear. You need to audit your current architecture against these specific failure modes. Look at where you are cutting corners and where governance theater is substituting for actual control. The difference between a useful tool and a corporate liability is the presence of these controls. Trumpify was a diagnostic tool, but it was never the destination. If this changed how you think about AI systems, follow me, Mirko Peters, on LinkedIn. And if you want more of this deep dive analysis, leave a review so more people can find it. Share this with your team, especially if you are dealing with these exact problems right now.